Good morning, calculus class today. So this one is for the lecture section 1.3. So it's new functions from old functions. So it's all about the composition. So for the first one, okay, so let's just do not worry about the graph here on the right hand side. So this one, something wrong with that. Okay, so given the graph of f, okay, so here is given f of x, kind of like absolute value or piecewise function. And then you want to sketch the following function. So you want to sketch the function with negative f of 1/2 x. So for the student that might be wondering, we don't know exactly what the function is. So how do we sketch the graph? Well, the thing is that we do have a graph given already, the original graph or the parent graph. So what we need to do with the transformation. So this one, basically, that comes along with the composition. So first thing that you want to do, whatever the value of x that you have, you always want to convert that to 1/2 x. So basically what we can do, we can set up the column. So x, and then 1/2 x. And then whatever that we have for the results of 1/2 x, we want to put it into f of x. And then the final result we have, we want to convert that to its negative. So that means we want to convert that to its reflection over the x-axis. So one thing at a time, so let's choose some random points on the graph right here. So let's choose this point, this point, this point, and the one over here. So as you guys can see that what I did, I actually choose the end point or the midpoint of the line segment. So basically you can find out exactly what the new position is going to be like. Okay, so again, we're going to sketch the graph, the final graph here on the same xy plane. So one thing that we have, so for the first one, we do have 4, 0. So we started with 4 here. So 1/2 times 4, then that'll be considered 2. So what we need to find out, it's f of 2. So f of 2, according to the original function, f of 2, well actually this one is negative 4, excuse me, so let's start it over again. So negative 4, so negative 4 times 1/2, then that'll be negative 2. So it's actually f of negative 2. So f of negative 2, then that'll be right here. So f of negative 2, then that's considered 2 because the scale is by 1. So we got 2. But don't forget, eventually we want to flip this one over. So once we flip it over, so it's going to be negative 2. So starting at this position, so it's going to be negative 2. So that's down here. So that means when x equals negative 4, so the final y value would be considered negative 2. And then we use the exact same, well, we go through the same process, but this time we choose negative 2, 2. So for the value of x is negative 2. So negative 2 times 1/2, we do have negative 1. So f of negative 1. And again, according to the original graph, f of negative 1. So that it's all the way up here, which is what, 1, 2, 3. So that's 3. And then we want to do the reflection over the x-axis. So reflected over the x-axis. So it turns out to be negative 3. So for this position, it's going to be down here at negative 3. So once again, we find those points. And now the next positions, so the next spot here, so we do have 0, 1, 2, 3, 4, 0, 4. So for the x value, we use 0. So 1/2 times 0, that's 0. So f of 0, which is the original position. So that would be what? Negative, no, that's positive 4. But this time, don't forget about the reflection. It's over the x-axis. So it's reflected over the x-axis. So it's going to be negative 4. So 1, 2, 3, 4, all the way down here. And now the next one, the point that we choose. So this one, it's 2, 1. So when x equals 2, so 1/2 times 2, then that's 1. So f of 1. So f of 1, we do have 1, 2, 3. Well, it's actually 2.5. It's right between 2 and 3, so 2.5. Convert that to its opposite, so it's negative 2.5. So negative 2.5. So that position right there is going to be negative 2.5. Right here. And then the last position, we do have 4, 3. 4 comma 3. So this one plug in 4. So 1/2 times 4, that's 2. F of 2. So f of 2, which is 1. According to the original graph, f of 2 is 1. So negative 1. So negative 1, so that's all the way down here. And then once we get those dots, guess what we can do? We can connect them. So eventually the graph is going to be like this. And now for those you might be wondering why this one it's a little bit flat. Well, the reason why that is, the 1/2, it's considered a horizontal stretch. If you guys do recognize that, the structure, so the function is considered y equals a times bx, and then the quantity minus h plus k. Or we can say that with the absolute value. Can always say that, that b right there, it's just like a scale factor, but it's a horizontal stretch or horizontal string. So that's why the graph looks a little bit flat right here. Even that this one shows some kind of like a turning point, but eventually it's going to be flattened out. So then that'll be the final graph. Okay, so now to look at that, the other example. So what we got here, this one is using transformation to sketch the graph. As you may notice, for cosine of x, we do know that it's a bell curve. So you started with the bell curve for the parent graph. So let's say this one here, that's 1. Down here, which is negative 1. And that through the whole cycle, that's from 0 to 2 pi. Okay, 1, 2, 3, 4 pi. 1, 2, 3, 4. You can always customize the scale. You can change the scale for the x-axis, the y-axis. Okay, so once you sketch the graph, so this one, it's considered one full cycle. So this one is pi over 2. 3 pi over 2. So it started at 1 because cosine of 0, that's 1. Cosine of pi over 2, that's 0. Cosine of pi. Again, I'm just making the parent graph of cosine of x. And then cosine of pi, that's negative 1 down here. Cosine of 3 pi over 2, that's 0. Cosine of 2 pi, then that'd be 1. If that's a parent graph, so this one should be dotted, because this one is not the final graph yet. And one thing that we notice for cosine of x with the absolute value, so that means everything is going to be right here above the x-axis. Well, because that, for absolute value, it makes all those values to be positive. So let's just change the color here. So this time I would like to use blue. So for the final graph, again, everything is right above, so just leave it. And then down here, so you want to reflect it over the x-axis. So instead of being negative 1, so at pi, so it's going to be 1. And then for the rest of the curve, just continue with this. So eventually it looks like a W shape, but the thing is that this one is a curve. It's not a line graph. And now what about for the quadratic? Absolute value quadratic. So the first thing that you want to do, we want to convert the quadratic into the vertex form. So we got y equals absolute value. So x squared minus 4x plus blank. And then here, minus the blank. So the way to complete the square is b over 2 quantity square. So it's negative 4 over 2 quantity square. So which is negative 2 quantity square, so that's 4. So add 4 here, and then we subtract 4 at the same time because we want to balance the equation. So what we got here is absolute value of x squared. Well, let's just factor the trinomial, the first 3 terms. So once you factor it, so it's x minus 2 quantity square, and then minus 4. So as you may notice, so the transformational form for the quadratic function, the vertex form, it's a times the quantity of x minus h squared plus k. So 2 and 4, well 2 and negative 4, so that's the vertex. So 2 and negative 4, that's the vertex. So again, we just want to sketch the parent graph first. So 2 and negative 4. 1, 2, 3, 4 down here. And then we can find the y-intercept. So the way to find the y-intercept, we can set x equals 0. So 0 minus 2, which is negative 2. Quantity squared, so it's 4. 4 minus 4, so that's 0. Again, the vertex, that also shows the line of symmetry. So that means the other point is going to be reflected over the line of symmetry. So 2 units away. Again, this one is just a parent graph without the absolute value, so it's dotted. Again, absolute value, one thing that we shows here. So this one, everything's right above the x-axis. So everything's that's down below, so you want to reflect it over the x-axis. Okay? So eventually the graph is going to be like this. Everything's right above, so just leave it. And then everything's right up here, so this one's going to be reflected, this half of the parabola. So this one is down 4, so that means up here is going to be 4. And the other part here, so this one is just a continuation. And that's going to be the final graph. Okay, so now let's see what else that we have for the rest of this. Okay, so composition functions. So fog, that means it's considered f of g of x. So g of x is considered the inner function. And then whatever the result we have for g of x, we put it into f of x. So f here, then that would be considered the outer function. And then fof, that means it's f of x. And then gof, that means it's g of f of x. And then for gawk, that means it's g of x. So that means we have to use the function twice. So one is for the inner function, the other one is for the outer function. And sometimes this one can be written as f o g o h. So that means it's considered f of g of h of x. Okay, like that. So now let's do one example like this. So find f plus g, g times f, and then g over f. Well, this one is just about the function operation. So for the first one, so basically we just want to set that f of x plus g of x. So we do have square root of x squared minus 1. And then g of x, we do have square root of 3 minus x. Well, the thing is that they do have the exact same radical, but the different radicand here. So that means we cannot combine those terms. So the only thing we can do, we can just leave it like that. And now for the next one, we do have g times f, so which means that g of x times f of x. So what we got is square root of x squared minus 1 times, it's actually the other way around. So g of x first. So for g of x, so we do have square root of 3 minus x. And then for f of x, we do have square root of x squared minus 1. So for the radicals, so this one basically just multiplied the radicand. So it's the square root of the rest of the binomial inside the radical. So we just need to FOIL. So 3 times x squared, we do have 3x squared. 3 times negative 1, so we do have negative 3. Negative x times x squared, so negative x to the power of 3. And then negative x times negative 1, so we do have plus x. And for those you might be wondering, do I need to rewrite this one from the greatest power to least? Well, it's up to you. So we can just leave it like that. Again, nothing we can combine. And then for the quotient, we do have g of x divided by f of x. The slash, that means the division. So g of x, we do have square root of 3 minus x. And then for f of x, we do have square root of x squared minus 1. And for those you might be wondering what we need to do here. So back to pre-calc. This one, anytime you see the radical down here, that means we need to rationalize it. So that means we need to multiply the top and the bottom by the same denominator. So square root of x squared minus 1, square root of x squared minus 1. Because the thing is that we are not allowed to leave the radical in the denominator. So the top portion is just like what we got for the previous one, so which is square root of 3x squared minus 3 minus x cubed plus x. See that everything is inside the radical? And then for the denominator, so once you multiply the exact same radical, so that means it's just x squared minus 1. Again, nothing we can simplify here. And once again, as long as you don't see any radical down the bottom, so that means it's the simplest form. Okay, so now, and for the rest of this one, it's all about this one is all about the composition. So f of g, so it's written as f of g of x. So that means for the inner function, we need to start it off with x plus 2 over x plus 1. And then the quantity that we have right here, whatever that we have for this whole quantity, we want to put it into f of x. So for f of x, we do have x plus 2 over x plus 1, and then plus 1 over, again, x, that's the variable, that's the original variable. So we want to replace this, the variable, by the whole thing. So x plus 2 over x plus 1. And then this one can be written as x plus 2 over x plus 1, and then plus, well, this one is just the reciprocal, so it's x plus 1 over x plus 2. Well, for those you might be wondering, can I combine them? Yes, you may. Can we just leave it like this with the setup? Yes, you can do it that way as well. And now for the next one, it's about g of f of x. Okay, so let's try the next one. So for g of f of x, so let me just change the color. So for g of f of x, so we do have g of f of x, which is x plus x, 1 over x. Again, whatever that we have for the inner function, we want to put it into the outer function. So for g of x, so that's going to be written as x plus 1 over x plus 2. As you can see that, I just replaced the x by this binomial, x plus 1 over x. And then over the x right here, again, replace that by the new binomial, x plus 1 over x, and then plus 1. And for those you might be wondering, can I simplify this whole thing? Yes, you may. So this one, you can just simply multiply the top and the bottom by x, because that's the least common denominator. So multiply everything by x, because you don't want to end up with the complex fraction here. Multiply everything by x. So we do have x squared plus 1 plus 2x. And then over the denominator, distribute. So x squared plus 1 plus 1x. If you try to rewrite it, so it's x squared plus 2x plus 1. And then the denominator, it's x squared plus x plus 1. Okay, so then that would be for g of f of x. It's a rational expression. And then for the last one here, so f of g, so that means we started with g of x first. So for g of x, we do have x plus 2 over x plus 1. Okay, so now let me get some space here. So let me just get rid of all this. So the first step is always easy. So that's just the inner function. But now we need to put in the inner functions to the outer function. So the first outer function here, so which is what? F of x. So we need to put it into f of x. So this one is written as x plus 2 over x plus 1. So we just replace that x by using the rational expression. And then plus 1 over this whole thing. So that means the reciprocals of this. So it's x plus 1 over x plus 2. So for the first set here, it's just like going back to the first solution here, f of g of x. And now we need to put in this one for f of x. So for f of x again, so that means it's going to be considered this whole thing, x plus 2 over x plus 1 plus x plus 1 over x plus 2. Well, this one is just a replacement of the original x. And then plus 1 over this whole quantity. So 1 over this whole quantity. So it's 1 over x plus 2. X plus 2 over x plus 1. And then plus x plus 1 over x plus 2. So for those you might be wondering, can I simplify it? Yes, you can combine those. You can find the least common denominator and then convert this one to the reciprocal form. So certainly you can do things like that from here. So basically just find the least common denominator, then that'll be considered x plus 1, x plus 2. The other one is pretty much the same, x plus 1, x plus 2. So this one we just need to multiply by x plus 2, top and the bottom. So it's x squared plus 4x plus 4. And this one here, multiply that by x plus 1, so x squared plus 2x plus 1. And then once you come up with the same denominator, that means we can combine them. So it's 2x squared plus 6x plus 5, all over the same denominator. So the other way to rewrite this one, so for that 1 over this whole thing, it could be considered the reciprocals of this quantity. You know what? Anything that's getting complicated like this, you can always just leave that as the setup. Okay, so now for the next one, so this one is about decomposing. So decomposing the functions, so that means we need to come up with the original setting for the inner functions, the outer functions, and then the second outer function. So this one is always in the structure of f of g of h of x. So the way to figure out the function one at a time, so it's all about using the PEMDAS. So let's say that you plug in a number into x right here. So you're asking yourself what you want to do. So according to PEMDAS, you want to start it with the parentheses first. And anything inside the parentheses, that means we started with the exponent. So the exponent would be considered x squared. Okay, so you started with the inner functions. So the first one, you started off with h of x equals x squared. And then you want to ask yourself again, so after x squared, what would you do next? So the next step, you want to subtract the quantity from a. So that means a minus x. So that would be the outer function. And then the last thing that you want to do, it's about 4 root of the whole quantity. Okay, so once you decompose the functions, so the first one, x squared, outer functions, a minus x, and then the most outer functions, then that'll be 4 root of x. And then for this one, it's quite similar, using that the root of PEMDAS again, along with that f of g of h of x. So the inner function, we started with the square root. Outer function, g of x, so that means we're taking that with cosecant of x, cosecant of the quantity. And then for the last thing that you want to do, so you want to raise out whatever the result you have from cosecant, and then you want to take that to the 5th power, so it's x to the 5th power, or x to the power of 5, and that would be the final form. So first, second, and third. Again, this one just shows the order of what you're doing first, second, and last. Inner, outer, most outer. Okay, so now let's see how many more slides we have. 2 more slides here. So evaluate the following expression from the given graph. So what we got here, so the black curve here, the piecewise function, which is f of x. And then the red one, the check, that's g of x. So now we need to find out the exact value for this. Okay, so let me just erase this. This one is just the setup here. Okay, so let's start it over again. And then the scale, as you guys can see that from each the box here, so that's considered 1 unit. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, so on and so forth. Same thing happened with the y-axis. So for f of 2, so let's find out what that is. F of 2, so the black curve right here, so f of 2, which is 5. So we want to put in 5 for f of 2. And then g of 5, so 1, 2, 3, 4, 5. So let's find out what that is. So for g of 5, which is 4. And then for the next one, so f of 4. So let's find out f of 4 first for the inner function. So f of 4, 1, 2, 3, 4, all the way up here, which is 3. And then using the same function again, find out f of 3. So f of 3, so 3 is here. 1, 2, 3, 4, about 4.6 or 4.7. So this one is about 4.7. So this one is just basically read through the graph, and then you want to find out the exact value for the composition. Okay, so now let's see what else that we have for the rest of this. The last one. So again, this one is just the compositions. So for V circle R, so that means it's like V of R of the variable. Whatever the variable that is, looks like that the variable is T. So it's V of R of T. So we started off with the inner function, the radius function, which is 3t. So we just convert that to radius with respect to the time. So this one is a radius. T, that means the time. And then we want to put it into the volume of a sphere. If you guys do recognize the function for the volume of a sphere. So volume of a sphere is 4/3 pi r cubed. So let's say that we do have a sphere. Okay, so a sphere. It's not a circle. It's a what is it? It's a ball. Okay, so that means it's V of 3t. So we want to put in 3t for r here. So it's 4/3 pi. So instead of using radius, so radius this time we're using that as 3t because we convert the radius with respect to the time already. And then don't forget to the third power. So eventually it's 4/3 pi times distribute the power. So we do have 3 to the power of 3, which is 27 t cubed. And then the rest of this we can just cross cancel, excuse me. So 3 goes into 27 9 times, so the 3 is gone. So 4 times 9, which is 36. So 36 pi t cubed. And that would be considered the final V of R of t. So any question, any concern that you have, so you're more than welcome to join us for the office hour. You can join us for the after school tutoring. And also you can fast forward, you can rewind the videos, so just watch any spot, things that you're kind of getting struggle. Alright, so I'll see you guys next time. Take care.